Here we have the equation of some kind of curve where x and y are related, and we're asked to find the coordinates of the stationary points. So remember, stationary points are those points where dy by dx equals 0. So we need to differentiate to find dy by dx and then solve dy by dx equals 0. But what we have here looks like we're going to need implicit differentiation because we've got x and y multiplied and added together in the same expression. So let's differentiate this term by term. So 5xy, that looks like it's going to need the product rule, but the others seem like they're fine. So 5xy, when you differentiate that, the derivative of 5x is 5, and then you multiply that by y plus 5x times 1 dy by dx. So that's your product rule. And then the derivative of y to the power 4 is negative 4y to the power 3 dy by dx. That's equal to 2x plus 0. Okay, so that's the implicit differentiation out of the way. Now we need to rearrange to find dy by dx. So anything that doesn't have dy by dx in it, we can move it to the other side. So we end up with dy by dx, if we take a common factor, 5x minus 4y cubed equals 2x minus 5y. And therefore dy by dx is 2x minus 5y divided by 5x minus 4y cubed. And for the stationary point, we want to solve dy by dx equals 0. So we can say that the numerator is equal to 0. So 2x minus 5y equals 0. So you can think of it as multiplying both sides by the denominator. So the numerator is equal to 0. So that gives us 2x equals 5y, and y equals 2 over 5x. So that's really helpful. Now we have y in terms of x. So now our function, the curve that we were given, we can now rewrite that, replacing every y with 2 over 5x. So I can now take the original function from up there and replace y. I've got two instances of y, one there and one there. I can replace those with 2 over 5x. So now I have 5x times 2 over 5x minus 2 over 5x to the power 4 equals x squared plus 9. So that 5 cancels with that 5, and we end up with 2x squared minus 16 over 625 Yep, that's right. x to the power 4 equals x squared plus 9. So to get rid of the denominator, how about we multiply everything by 265? At the same time, let's bring this to the other side, and the same with the 9. So that will give me 625x squared minus 16x to the power 4 minus 9 times 625 is 5625 equals 0. And if I try multiplying everything by -1, that will allow me to write this as a disguised quadratic. So I'll have 16x to the power 4 minus 625x squared plus 5625 equals 0. So now we have a quadratic, and we can solve that really easily. So we can say x squared equals 625. So I'm using the quadratic formula. You can probably factorize it, but I'm just going to go ahead and use the formula. So negative b plus minus square root of b squared minus 4 times 16 times 5625 divided by 2 times 16. If you put that in your calculator, you're going to get x squared equals 25. Or x squared equals 225 over 16. So we can take the square root of both. So we now have 4 solutions. We've got x1 equals -5, x2 equals 5, x3 equals -15 over 4, x4 equals +15 over 4. So now we have 4 x coordinates for our stationary point. We now need to find the 4 y coordinates. And we do that by simply substituting y equals 2 over 5x. So if we substitute y equals 2 over 5x into each of these, then we can find y1, y2, y3, and y4. So 2 over 5 times -5 is -2. So that's y1. 2 over 5 times 5 is +2. 2 over 5 times -15 over 4 is -3 over 2, and y4 is +3 over 2. So now we have our 4 x coordinates and our 4 y coordinates. So these are the coordinates of the stationary point. So there are 4 of them. The question doesn't ask us to find the nature of these stationary points, whether they're minima or maxima or inflection points. It just asks for the coordinates. So that now is our final answer. Now remember, the way we did this was by implicit differentiation, and that gave us an expression of y in terms of x that we used to turn the equation that had y and x in it into an equation in terms of x that we could then solve. Once we knew x, we can then easily find the coordinates by finding the corresponding y's. So that's how you answer a question like that.